Welcome to the Develop Yourself podcast, where we teach you everything you need to land your first job as a software developer by developing yourself, developing your skills, your habits, your network, and more. I'm your host, Aaron Hayslip, and today we're going to be going over how to build a web app. We're going to go step by step through how a web app works, the different languages and frameworks that you need to build a web app. And we're primarily going to be doing this by giving you an example of how Twitter.com is built and exactly how tweets work. Okay, we had an episode back, I think it was episode 9, a complete guide to learning JavaScript, and it was one of the more practical episodes we've had. It got a little technical. We usually don't get technical in this podcast because this is more about all of the other stuff, habits, the stuff that I talk about in the intro. But today, we're going to be talking about how to build a web app, and it's less of a how-to because it's impossible to give you a how-to on the internet, but just like the JavaScript episode, this is going to be an episode all about context. And as we said in that episode, context is really important for beginners because oftentimes you'll dive into some kind of Udemy course about some niche topic, whether it be JavaScript, React, or Node, or whatever it is, and it's impossible to follow along because you just don't know why it is you're learning that thing or what the end result of putting all of these pieces together will be. What does this actually look like whenever you're finished? And that's what we're going to be talking about right here, is building a web app. So that being said, we have to start with the beginning, and that is, well, what is a web app and why is a web app or web application, why is it important? Why should I care about building a web app? Well, if you want to become a software engineer, building a web app is probably what you're going to be doing every day at your job. And that's because most software engineering jobs these days are actually web development jobs. And I need to define web development here because it's not maybe what you think it is. Probably about 10 or 15 years ago, web development meant that you knew HTML and CSS, which was a pretty desirable skill to have back then. Not a lot of people knew how to write HTML and CSS. And by the way, if you don't know what HTML and CSS are, we're going to explain that here more in a minute. But that's not what web developer means today. Oftentimes today, you'll hear the word web developer, software developer, programmer. They're used a little bit interchangeably. That's because, like I said, most software development, most software actually tends to be a web application. And a web application is basically, it's an advanced website. Most products you use on the web, if you're using them on your computer, are actually web applications. So let's think about Gmail, Facebook, Instagram, Twitter, LinkedIn, QuickBooks Online. I mean, anything that you might be using day in and day out on your computer is probably a web application. If you go to a website, it is a web application. Now, what other kind of applications are out there? Well, pretty much the only other one that you probably care about too much, unless you've got an Apple Watch, is an iOS app or an Android app. So depending on what kind of phone you have, you might have an app on your phone. But basically, even those apps these days work really similarly to the way that web applications work. And then if you're asking me, well, I thought programmers did a lot more hardcore stuff than make websites. And some programmers do. There are all kinds of programmers out there. There are hardware developers who build devices. There are everything you can think of. There's very niche software developers for every little thing that happens in the world. There's even software developers for helping build automated tractors for John Deere. But probably if you're looking to become a software engineer, you're looking to get into web development. Now, maybe you don't believe me. If you don't believe me, let me ask you this. When's the last time you went to Best Buy, if you still go to a Best Buy? I haven't been to one in years. But when's the last time you went to Best Buy and you bought software? I mean, probably, I hope it's been at least 5, maybe even 10 years. It's been more than that for me, I think. Like whenever you go to Facebook, right? Whenever you go to Facebook.com and you get a new update of Facebook, you didn't have to go to Best Buy to buy Facebook, right? But if Facebook had been created in the late 90s, then you would have bought it at Best Buy. And every time they changed the layout, they would prompt you to go to Best Buy and buy a new one, right? I mean, that's what you did whenever you played The Sims or Oregon Trail. I don't know how old you are or if you play those games, but you had to buy those games at Best Buy, bring home the CD-ROM, and put it in your computer. And that's why web applications like Facebook, gosh, I mean, it's probably a terrible example, but web applications like Facebook are so awesome because when they get updated, It happens immediately. The next time you go to the website, suddenly the software has been updated. And this has happened, by the way, because technology has just become more powerful. The internet is much faster, it's much better, our machines are much better. So we no longer have to have these very long, slow development cycles of releasing new software and then physically selling that software. You could just build a web app, access it instantly. And even if something breaks, right, it doesn't matter so much if it breaks. If it breaks, we can fix it in an instant. We can push it up and people can have the new version of that application. So all that to say, I keep saying all that to say, but all that to say, web apps are where it's at. And that's probably what you're going to be working on if you become a software engineer right now. That, or you're probably going to specialize in development for some other platform like Android or iOS. But fear not. If you learn the things I'm talking about in this episode, you are going to easily be able to transfer that knowledge and those skills into building for phones and other kinds of platforms. Because at the end of the day, building software is building software. Your frameworks, your languages might change a little bit, but overall the patterns are similar across platforms and devices. With that, let's start talking about the anatomy of a web application. We're first going to start off by referring to the two main parts of a web app, the front end and the back end. You've probably heard people use this lingo before. They're either front end developers or they're back end developers, or you might hear them say things like they are full stack developers. They do a little bit of all of it. So we're going to start here by talking about the front end. The front end is the part that the user actually sees. It's the website side of a web application. So whenever you go to a website, whether it be google.com or facebook.com or whatever, what you're seeing is HTML and CSS, right? So HTML and CSS are the basic building blocks of every website. So every browser that you use, by the way, a browser might be Google Chrome, Mozilla Firefox, Safari. Those are the typical browsers you might use. There are phone versions of those as well, probably the most popular being the Safari browser that exists on Apple devices. But anyway, so you go to the website and it loads up HTML and CSS. If you've ever looked at HTML before, you know it's this funny little tag kind of language where you're writing readable text inside little brackets and different things like that. If you don't know what HTML is, you've never seen it, go ahead and Google it at some point to check it out. But oftentimes it's described that the HTML is kind of the skeleton. It's the structure of a website. It gives you the content, and even some other kind of metadata that you wouldn't actually see. So it might help screen readers explain what the content is for accessibility type features that might exist, like screen reading. And then what makes that website actually attractive or gives it its style is CSS. So both HTML and CSS are what we consider markup languages. So they're not languages in the sense of they don't have a logic, there aren't conditions. You're not saying if this happens, do this. It's just basically we write this and then it makes it look like that. There's no logic or decision making that's happening in your code. There is no real processor that needs to run the code or really compile it. It's just the browser sees the markup language and then shows the user what the user needs to see. So that is part of the front end. It doesn't explain the entirety of the front end. The next part of the front end that we need to talk about is JavaScript. So on its own, if you have a website or a web application that just has HTML and CSS, it's going to be a pretty boring, i.e. not dynamic website, right? It's just going to show you the content that the programmer or developer wanted you to see. So that being said, I bet you this weekend, if you haven't already done something like this, you could pick up an HTML, CSS book, or probably what's better is an online course, and you could build a website in an hour. It's probably not going to be that good or that pretty because CSS, though it's simple and you can get up and going immediately, it's pretty tricky to learn it extensively. Now, the JavaScript is what is going to make that content actually dynamic. So by dynamic, I mean whenever you click a button, if you want something to happen, usually JavaScript is going to make that thing happen. Now, what do I mean by make it happen? What is it that we expect to happen? Well, one example is if you fill in a comment box and you click comment, you expect a new comment to pop up, right? That's an example of something you might see on Facebook or a variety of other web applications. So when the comment pops up, it's obviously not magical. It didn't just appear out of nowhere. What's happening is the JavaScript is generating in real time some fresh HTML and CSS. And then it's either injecting that HTML or it's hiding or showing that HTML. It's doing something dynamic with the HTML. So at the end of the day, JavaScript isn't doing anything but arranging, changing, adding, removing HTML. And that explains pretty much all of front-end development. There are some very complex ways to do this because our websites, our front-end web applications become very complex. And that's when you end up needing things like React or other frameworks that you've heard of to make this job a lot easier. We're going to dive into that a little bit more deeply in a few minutes here. But to understand any more complexity about the front end, we've got to understand what the back end is. So the back end is essentially responsible for any of the data management. So think of any application that you use regularly, whether it be Gmail, Twitter, Facebook, and let's think about the data that is involved in that application. So for Facebook, you've got the news feed, you've got posts. For Gmail, you have emails, and the reality is those things have to be stored somewhere. And how they get stored can be a little bit complex, but at the end of the day, basically they get stored in some kind of database. And a database is basically a software storage system that is optimized for different things depending on the data and how often it needs to be accessed. So probably the main categories of databases you hear about often are NoSQL and SQL databases. Basically, SQL is a database language that looks at data sort of like a spreadsheet. You've got tables and you've got different rows, and there are relationships between those different pieces of data, which is also why oftentimes you hear SQL databases called relational databases. The other kind of database that you hear about most often is called a NoSQL database. The most popular of these is MongoDB, and obviously DB standing for database. And the idea of Mongo is that you can store large amounts of data in an unformatted way. So each of these types of databases have different pros and cons, but all to say, let's imagine for the sake of our example of starting out small and simple, that a database is essentially a method for storing data and then accessing that data later whenever we need it. And that's essentially the point of the entire backend when we think about our web application. So for example, whenever you post something on Facebook, you're going to send the data of that post to Facebook, and Facebook is going to put it into their database. Now that happens, lightning fast, because almost immediately someone else is going to pull up Facebook, and then Facebook is going to go and get that post from their database and then display it to that user. Now, obviously, the back end isn't just comprised of a database. There's an entire layer that sits on top of that database that allows the front end to communicate with the database, and that's usually what we refer to as our API. Now, even in this, the term API can be kind of confusing because the term API is a much more general term than we often use it for. API stands for Application Programming Interface. Now, interface basically being the way that you can interact with something. So an API is just a set of ways that you can interact with a certain application. And in the case of a web app, usually what it outlines is a set of URLs that the front end can utilize to send and retrieve data. And by the way, the reason for this whole backend layer is because the front end doesn't have any data, right? There's no storage really on the front end. I mean, the exception would be in the browser, there are cookies and there are local storage. There's a couple other small items, but this isn't optimized for storing large amounts of data. Essentially, whenever you get off your computer or you turn the internet off, all of the posts and all of those things that you saw on your computer are no longer stored on your computer. The internet stores very little data actually on your machine. That data gets stored somewhere else, like we talked about in a database. So the backend developer, they're going to be in charge of setting up the database, making sure everything works properly. They're also going to be in charge of setting up this API. And this API is, like we said, basically a bunch of URLs that dictate how the front end communicates with the backend and ultimately communicates with that data. An analogy you could use here is sort of like a warehouse. And we could even probably think about Amazon's fulfillment centers. And inside of an Amazon fulfillment center, it's basically a big warehouse with a ton of inventory. They've got products. I mean, everything you could ever think of is stored inside this fulfillment center. And then basically the job of the people who manage the fulfillment center is to create ways in which the delivery drivers can come and access that inventory. So that's actual delivery drivers trying to get inventory that their customers, that the Amazon customers have ordered. And then there are also suppliers, right? These are manufacturing companies who are actually selling the products. They come and they deliver the products to the fulfillment center. So the fulfillment center in some ways acts as a storage facility and a general dispatcher, helping to get products from producers, so whoever creates a product, out to the consumers who are purchasing and consuming these products. So the same is sort of true with back-end development. The back-end is essentially the place where the front end, right, the end users, Facebook users like yourself, they're creating data by adding pictures, posts, etc. The data then goes to the back-end. There's a mechanism by which they can send it. There's a URL that they can make a request to. We'll talk more about requests here in a moment. The backend then stores it somewhere so it can be easily accessible again later, just like in the warehouse. Whenever the producers of these products bring them to the fulfillment center, there's someone in the warehouse saying, oh, this is the place to put the pants, right? This is the pants department. So when someone orders pants, we can quickly, easily, efficiently, proficiently bring the pants out to delivery drivers, right? And so that's what happens on the back end as well. Okay, so far we've introduced both of these parts. We're going to dive into each of them in a little bit more technical detail now. The front end is what the user sees, how the user interacts with it. It's ultimately HTML and CSS. It's a website that the user interacts with. JavaScript helps make the website more dynamic by adding and removing HTML and CSS to make it feel like it's something that you're actually interacting with. It makes for a good user experience, right? And then the back end is the one that's managing the data, right? Whenever the front end loads up the page, the back end says, oh, cool, we're going to deliver you the data you need. When the front end creates some more data, the back end says, oh, cool, we'll store that data for you later because you're going to want to see it again whenever you load the page back up or whatever, right? Okay, so it's at this point that we need to talk about one of the most important mechanisms of the internet for actually sending and receiving data, which, by the way, this is a whole other topic. But the internet, right? The internet's what makes this all possible. And the internet, by the way, is just a series of connected computers, right? You have some data, I have some data, our computers are connected, they get to communicate. Now you might be saying, yeah, but Aaron, you told me that my computer is not storing Facebook data. Well, not necessarily, it's not. In fact, we have these special computers called servers. And the servers are literal physical computers that are housed in these massive data warehouses, and it's where the raw data of any of these applications actually live. Now, if you didn't know this, it will freak you out to Google data center, and you will see these massive, 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 massive facilities with thousands upon thousands of very powerful computers. And ultimately, that's where all the data for all the internet's thingies are being stored around the world. And it's freaking crazy to think about. So probably your Facebook posts live there. Now, if you're thinking to yourself, and this is a rabbit hole here, but well, what happens if one of those gets bombed or something? Usually there's redundancy, right? Facebook or these big tech companies, they've got the data stored in such a way where if something goes down, it's going to be redundantly copied somewhere else. There are different ways of handling that. And that's a whole nother area of tech and tech jobs, by the way, that are out there. But the technology that allows us to do this communication is called HTTP. HTTP stands for Hypertext Transfer Protocol. And really, it doesn't matter if you know what that is or if you care about what that is, but this is essentially the mechanism by which the internet works to communicate between computers. Now, if that freaks you out and confuses you, just think about the mail system we have in our country, right? There's a certain protocol, right? There's a system, there's an agreement upon how we send mail in the United States. We have an envelope. We have to write the name of the person, their address, their city, state, zip code. And then the top left of the envelope, we usually write the return address, like where is it coming from? And then we're able to send it. We add a stamp for payment because it costs a little bit of money to send it. And then, the mail system takes over. They come pick it up and they deliver it where it needs to go. There is a system set up for that. The internet is the same. HTTP is a protocol. It's a system for sending data across the internet. So every time you send data on the internet, you're making what we call a request. Now, the request isn't always asking for something, so that word request can be a little bit confusing, but usually on the internet, the most common HTTP methods, in other words, the most common things that we're trying to do as relates to sending and receiving data are the following. And there are going to be 4 of these, and these are the 4 most common HTTP request types. The first one is GET, just G-E-T. So sometimes we make a request over the internet to try and get data. We're asking for something. So in the case of, whenever you go to facebook.com and load it up and your feed full of all that obnoxious stuff loads on your computer, what's happened is your browser, your computer has made a GET request to Facebook servers saying, hey, would you mind giving me the data that is supposed to be Aaron's Facebook feed? And then it responds and it gives you the data. We'll talk about response here in a moment. So that's the first one, GET. The second most common type is a POST request, P-O-S-T. A POST request means you are trying to send data. So this happens, again, we're using Facebook as an example. Whenever you post something on Facebook, see what I did there, post. Yeah. So when you post something on Facebook, whenever you create a new post to a wall or a comment or something like that, you are creating brand new data that Facebook has never seen before, right? Your text. What's going to happen is your computer is going to make a request to Facebook servers, and it's going to be a POST request, and along with it, it's going to send data. So you're telling Facebook, hey, I need you to store this data so that whenever another user across the world logs on and then they make a request for it, a GET request, they can see it. So a POST request is whenever you create new information. The third type of request we're going to talk about here is a PUT request. Kind of weird because GET made sense, POST made sense, PUT doesn't make much sense. PUT, P-U-T. A PUT request is whenever you have some piece of data, an entry that already exists and you're wanting to update it. So maybe you made a post on Facebook and you regret some of the things that you say. I wish more people would regret the things they say on Facebook. And you decide to edit your post. What's going to happen is you're going to make a PUT request. You're telling Facebook, hey, I know you've already got this post sitting in your database. It looks like this. I no longer want it to look like that. Please make this change. And it's going to make that change. And then finally, the fourth type of request, probably the most straightforward one, is a delete request. And it's literally called the delete request. And a delete request obviously requests that an item be deleted. So in this case, your Facebook post was so awful that you're like, please, dear God, Facebook, destroy that post, and they will delete it. But as you probably know, the internet is forever, so somebody might have seen it. If they care about it, they've saved it anyways as a screenshot or something else. But anyway, that's beside the point. Those 4 methods make up the protocol, the structure by which we communicate on the internet. And by the way, this is how your front end and your back end are communicating. And in most cases, they're separate. The front end exists somewhere else and the back end exists somewhere else. And they communicate via HTTP to send data back and forth. By the way, every time you use one of these web apps, there are a ton of these requests happening in the background. You're just not seeing them, other than maybe seeing new things load up on the page that were created based off of the new data that the app might have got or might have destroyed if you made a delete request somehow. But that being said, every time a request is made, there must be some kind of response. And that's a huge part of the backend as well, is figuring out how to codify and write these requests and responses so the front end can get what they need, or so the front end can know why they did not get what they need. Maybe there was an error of some kind with the database, or they didn't have access because of authentication or security issues. Okay, so now that we know in essence what the front end is, we know what the back end is. It deals with data, right? The front end deals with users. And now we know a little bit about how they communicate with each other via HTTP. Let's take it a step further and let's just walk through an example of something that's common that you would do on the internet. So bear with me here. In great technical detail, we're going to walk through 2 different scenarios. The first is you load up twitter.com. So literally you open up your web browser, you type in twitter.com, you go to the website, and it loads, and you don't touch anything else. We're going to walk through technically what's happening at every step to get Twitter loaded in your browser. And then we're going to walk through the process of actually tweeting a tweet. Like, how does it go from the text in that text box that you're typing to actually becoming a tweet that the whole world, or at least your followers, have the potential to see? All right, let's start. So we're going to sit down at your computer. You're going to go to your browser. Maybe your favorite browser is Google Chrome, whatever it is. You're going to type in twitter.com. Now, for the sake of this example, and you're going to know why I'm saying this right now, we're going to assume that you're already logged in. You don't have to re-log in. You're going to go to twitter.com, and immediately you're going to see your Twitter feed. Now, what's going to happen, and this is all going to happen like lightning speed. It doesn't seem like it's this many steps, but it is. Whenever you type in twitter.com into your URL bar, right, the little top bar at the top of your browser, what's going to happen is your browser will make a GET request to that URL, right? So actually the browser, whenever you type something in the URL bar, it's always making a GET request. That's basically what you're doing, is you're making a GET request to that domain. Now, behind the scenes, there's something happening on the internets called DNS, which stands for Domain Name System. Now, technically, every server that exists on the internet, remember earlier we said that basically the internet is a collection of computers. They're all networked together. Think about you and your friends connecting all of your computers together, being able to share data. The internet is that exact same thing, just on steroids, like crazy, like millions and billions of computers connected together. And each one of these computers has a unique IP address. Now, IP stands for Internet Protocol, so it's not really relevant necessarily to this example, but what we're trying to say is just as your house has a unique address or you have a unique email address, your computer has a unique address as well. So Twitter's servers have a unique IP address. So you want to make a request, right? You're basically sending some kind of mail to Twitter's server's IP address. Now, that address has a bunch of numbers. It's a lot more technical and complicated than this beautiful twitter.com, which, you can remember twitter.com, you can type it in. So the domain name system is in place to make sure that we can have these pretty URLs while still accessing unique IPs. Okay, so once you make that request, you're actually sending a request to a URL that exists as a route on Twitter's backend. So basically, the backend of Twitter has a URL that says, hey, whenever a GET request is made to the root, basically whenever a GET request is made to twitter.com, let's send this back. And what Twitter's backend is actually going to send back in this case is an HTML file. Now, whenever you're building a backend, you're building an API like Twitter has, you can send back different things. Sometimes you're sending back JSON. We'll talk about that more in a moment. Sometimes you're sending back different kinds of files. It really depends, but the API can normally handle sending back different types of data to whoever requested it. Just like if you're trying to mail a package, you can mail a letter, you can mail a big box. In some cases, you can even mail large items like a car or something. You can ship whatever you want, really. So in this case, when we made a GET request to twitter.com through our URL bar, Twitter sent us back an HTML file. Now, as you know, the HTML file in and of itself is just some basic content. It's the skeleton of twitter.com. And by the way, you've probably seen sometimes whenever you load a website up and the CSS file doesn't load, it looks like you still see the same data, but looks real ugly and unformatted. It kind of looks like Craigslist, because Craigslist doesn't have much CSS happening. Anyway, that's what probably any given website would look like without a CSS file. Now, this HTML file that got sent back from Twitter then gets loaded in your browser, right? And your browser knows how to read HTML, so it loads in the HTML file and it starts walking line by line through it and trying to figure out what to do with each line. Now, throughout that single HTML file, there are probably going to be a few link tags and a few script tags. Well, you ask, what are link tags and what are script tags? This is kind of getting into the nitty-gritty of HTML, but basically link tags are ways that we are going to load in CSS files, and then script tags are ways that we're going to load in JavaScript files. So both CSS files and JavaScript files will be loaded up into the browser as well. So at this point in time, you're probably going to see almost immediately that twitter.com looks like twitter.com. It looks pretty. There was almost no delay, at least not a delay that the human eye could see, between the HTML being loaded and the CSS being loaded to make the HTML look pretty. Now, the same thing is true for the JavaScript file. It got loaded pretty quickly, so quickly that you couldn't even see there being a lag between the HTML file being loaded and then the JavaScript file being loaded next. But there definitely is a little bit of a gap because the HTML file, in fact, is the thing that's loading the JavaScript file. Okay, so at this point in the process, if you were to pause it, which again, this happens in basically less than a second. If you were to pause right here, you would have twitter.com. And if you go to twitter.com right now, check this out. You would have the title, the top bar. You might even have like the little input box where you can tweet, but you would have no data in your feed because we actually haven't made the request yet for that data, right? That data is going to exist as a separate request, a separate GET request to the Twitter server, or the Twitter backend is another way to say that. So at this point, the way that happens is the JavaScript file, when it loads, probably what it's going to have inside of it, one of the first things that it's going to do, it's going to have some code to say, hey, if we haven't yet made a request for this user's Twitter feed, let's go ahead and make a request for this user's Twitter feed. So then it's the JavaScript that is going to be making this GET request. It's the front end JavaScript that has been loaded into the browser. It's going to be making a GET request to Twitter's server. So Twitter's server, Twitter's backend, I'm using those words interchangeably, has an API method, basically has a URL route that says, hey, you can go to this URL. If you make a GET request to this, it will give you a user's feed. So probably what it looks like is something like twitter.com/feed. It's probably a little bit more complex than that. And it might be something like twitter.com/feed/ whatever the ID of the user is, because we specifically want, of all the data that Twitter has, we want whatever is the feed at this point in time for this user. Now, how the feed actually works and how it gets the data and how it's timestamped and what data gets included, that's all some complex backend work that's being done somewhere else inside of the code base. All we want is whatever that feed looks like right now. However, the backend has figured out how to store it. We don't necessarily know. So our front-end JavaScript makes a request to twitter.com for this user's feed. Now, at this point, you might be asking, well, does that mean we could get anybody's feed? And the answer is no. There is a security layer that's in place here that we don't really need to go into in depth right now. But probably what's happened is since you're logged in, right? And by the way, this dives into how authentication works. Since you're logged in, there is probably some kind of access token that has been stored in your browser. It's been stored as a cookie. And as long as you have that cookie kind of behind the scenes, under the hood there, every request that you send from the front end to the back end is going to carry that access token. And that access token is sort of going to act as your front end's pass to request data on your behalf as a user. So there's definitely some security in place that from the back end it says, hey, you can't have, Aaron's Twitter feed unless you tell me that you're actually Aaron. And since you're logged in, there's some mechanisms happening again under the hood that indeed verify that you are logged in and that you are who you say you are. So assuming that works, the Twitter server, the Twitter API, the Twitter backend is going to send a response back to that request, and it's going to happen pretty lightning fast. And it's going to send a bunch of data back to the front end. Now, this data is going to be structured in what we call JSON, JSON. If you've never seen it before, it stands for JavaScript Object Notation. And JSON, it happens to be based off of JavaScript, but it's sort of the global way that we pass data around the internet. Now, I said HTTP is the mechanism by which data is sent. JSON is normally the format that we use to send that data. If you've never seen JSON before, just do a quick Google search. You can see some data. It's very readable, but it's basically a series of JavaScript objects and arrays that are nested to model any kind of data that we might need for an application. Now, the backend, the actual backend itself, technically speaking, could be built using a variety of languages and technologies, maybe Python, maybe Ruby, maybe JavaScript, but most all of these languages that are used to build web servers have some kind of method to convert their data structures into JSON because it's sort of a globally agreed upon format for sending data back and forth. So the Twitter server is going to send this JSON, which is full of that user's feed, back to the front end. Now, if you want to dive into some JavaScript real quick, if you're familiar with it, it's probably going to be an array of objects, and each object is going to represent a tweet, and there's going to be some kind of order that they're in, hence an array. An array is always ordered. So it's going to send that data back to that same JavaScript file that originally requested it. Now, in the real world, this is where things get tricky as a front-end developer writing JavaScript code on the front end, because you've got to figure out what to do with this data. And To simplify all of this, and we're going to go into how this can become complex, and this is why we have frameworks like React or Svelte or whatever else that you use. But real simply, the job of the front-end JavaScript at this point is to take that JSON data and to convert it into HTML, and then to append that HTML on the page. So what this looks like to the end user is they loaded twitter.com, all these requests happened lightning fast, the data came back, and real quickly the JavaScript converted that data into HTML, which the browser can read and then redisplay. And obviously the CSS kicked in and made it look like tweets as we know them today, even though in reality it is just some HTML that was generated based off of some JSON data structures. And that is the process in which this initial data for twitter.com loads up. Now that same cycle, the request response cycle, which is the user does something, JavaScript is listening for the user to do something. JavaScript then responds from the front end with some kind of request to the back end. The back end responds with some data. The JavaScript then responds to the data coming back, creates some new HTML, and changes the page. That kind of cycle is going to happen all the time. It's going to happen over and over and over again as the user uses the application. So that being said, let's look at our second example. So we've loaded Twitter up. Now we're ready to tweet. Let's tweet like we would back in the old days. If you're on Twitter in 2008, 2009, if you remember, tweets back then were just people saying what they were randomly doing at the time. You know, eating a burger with Johnny or going for a walk. So let's imagine we tweet something inconsequential like that and just say we're doing something random that no one actually cares about. Immediately what we see is it appears on our feed as a tweet. That's what it looks like to the user. Now behind the scenes, kind of in slow motion, this is exactly how it works. In that front-end JavaScript file, the same one that was loaded originally when you went to twitter.com, there's some code that says, hey, let's start listening for clicks on this tweet button. Now, as soon as that button gets clicked, there is going to be a function in the JavaScript front-end code that responds that says, oh, the button was clicked, we should do something. Now, the following is what it's going to do. The first thing it's going to do is it's going to identify the input, right? The little tweet input with the text in it. It's going to say, let's grab the value of that tweet, or let's grab the value of that input, which is going to be the text, which is the tweet. And with that data, let's make a request to Twitter's backend, to the Twitter server. This time, since we're creating data, since we're sending new data, we are going to make a post request. Now, with a post request, we can usually send what we call a payload, basically some data. So we'll make that request to the backend. And by the way, the URL that we might be requesting might be twitter.com/tweet. It's probably not that. But if we make a post request to twitter.com/tweet, of course, we'll also need to have our access token, the one that's in the cookie. So probably what's going to happen is we'll be pulling out that access token from the cookie, sending it along with our post request to the Twitter server. Now, the Twitter backend, again, could be written in a variety of different languages. That server code is going to grab the body of that request that we sent, which has our tweet data. It's also going to verify that we are indeed who we say we are, because in the backend, what's going to happen is it's going to take that tweet data and it's going to store it inside of the database. And it's going to say, okay, Aaron just tweeted this tweet. Let's add it to basically probably like a log of tweets in the database that are associated with Aaron. Now, of course, it's at this time as well that, any feeds that rely on Aaron's tweet, so any followers that Aaron has, they'll also get this tweet data into their feed, at least on the database. They may not have requested it yet on their front end, but now it's being stored in the database. So the next time they refresh or they reload their page or they come to twitter.com, this tweet will now show up in their feed. So the backend's doing that work. It's got the tweet. It's stored it as data inside the database. Then it's going to actually send a response back to the front end. Because remember, anytime we make a request, we must get a response back. So the front end is going to get the response back from the back end. And obviously the front end knows what data it just sent. But usually the way we are going to code this on the front end is to not actually show that data on the front end until we get some kind of confirmation back from the back end. Because the worst thing that you could do for a poor user experience is to make the user think that the request worked. And if it didn't work, if the database somehow messed up, if the backend is somehow messed up, we don't want to display that data until we've got confirmation that it's been successfully saved in the backend. So the backend is going to send that tweet back. It already stored it, but now it's going to send it back, that data back to the front end as sort of a confirmation to say, hey, we got it. It's been stored. And then at that point, the front end JavaScript is going to do its thing to convert, once again, that JSON that is the tweet into HTML and show the user that they just successfully tweeted. And as I said, from here on, since that tweet is now centrally located inside of a database that exists on Twitter's servers, anybody that's following me on Twitter will now see this tweet as well. They'll be getting it from the exact same location. Their own front end browsers will be making requests to that same server for all their tweets. And if they follow me, then they'll indeed see my tweet as well. And then the front end code will, of course, just like we did in the very first example, it'll convert that JSON they get back from the server into HTML and see my tweet amongst all the other tweets that they might see in their feed. All right, now, these are the basics of a full stack application. And in particular, we would call this application a CRUD app, C-R-U-D. I don't know if you've heard of that term before, but CRUD stands for Create, Read, Update, and Delete. And honestly, most applications that you probably use day in and day out are CRUD applications. You can create something, you can read it, right? You can display it and see it, you can update it, and you can delete it. So you can create, read, update, and delete tweets, Facebook posts, emails. There's just all kinds of things that follow this pattern. And it's no coincidence that each one of these CRUD actions that happens in your application lines up with one of our 4 main HTTP request types, right? So the C in CRUD is create, which is also a post request. The R is read, which it lines up with a GET request. The U is update, which lines up with a PUT request. And then the D is destroy, which obviously lines up with the delete request. Now, the technologies you need to build a full stack application like this, they vary based off a number of things. Mostly it's complexity, right? How complex is the application you're building? And there are actually a variety of factors that contribute to complexity. It might be the scale of your application. So normally the scale has more to do with the backend. And by the way, there's a whole other discipline within software engineering called DevOps, which is mostly concerned with the capacity of a web application. So, if you've got millions of users a day, there are going to be a lot of server resources that are going to be spent keeping that website up. So that may not necessarily fall in line with, one of these front end or back end developers or full stack developers that's creating the application's features. DevOps is really responsible for the operations of the developers and the environment in which the application lives. So on the back end, complexity normally has to do with, scale and capacity. If you think about Twitter, however millions of tweets that there are in the world, any given moment, however many tweets they have to store in history. There's a lot that has to do with capacity and scale for the backend developers of Twitter. Now, the front end complexity is normally based off of the UI, the user interface. How complex is the actual UI? Facebook is notorious for this. Facebook is a very complex application. There are tons of things going on within the user interface. And at some point, as Facebook increased in complexity, the frameworks, the JavaScript frameworks that were available for them, and basically frameworks are implementations of tried and true design patterns. We won't really get into design patterns right now in this episode, but all to say, essentially, Facebook got so complex that they had to develop their own way of writing JavaScript on the front end. And that's what led to React, right? Facebook created React. You've probably heard of React. It is all the hotness right now. It's the number one front-end framework these days. And basically, you could just write all the things that Facebook does in plain JavaScript, but it's really, really hard, right? So a framework like React helps you organize the JavaScript. Just like any back-end frameworks like Ruby on Rails, you could just write Ruby. Rails helps you do it faster in a more organized way. Python, Django, etc. Oh, and by the way, since we do talk about JavaScript so much, it's worth noting that you could build the web server in JavaScript. And the way you do that is by using what we call Node.js. And by the way, the code itself isn't really any different. The difference between Node and then the JavaScript that you would write on the front end is the environment, right? So traditionally, we write JavaScript in the browser, and the browser is equipped with a JavaScript engine to basically compile and execute. It runs the JavaScript, reads it, and knows what to do with it. In 2009, a developer named Ryan Dahl extracted that engine from the browser and basically made it so that you could run it on a server. So that is what is now enabling us to be able to write JavaScript on the back end as well. You could literally put this runtime, the JavaScript runtime, on a server, and then you could write an entire application front end and back end in just JavaScript. Okay, I think that's a good stopping point for how to build a web app. Obviously, you're not going to be able to build a web app after just listening to this episode, but my hope is this gives you some context for how an actual web app works and what you need to learn next in order to start building your own. Now, usually on this podcast, we think more about the other stuff, the non-technical things when it comes to building software, but please let me know if you want more episodes like based off of downloads of our JavaScript episode. It seemed like this was helpful. So we'll keep doing more of these if you keep downloading and listening to these episodes more than the others. And don't forget, if you're looking to take a first step into learning to code, go to dev30.xyz, where we're going to be launching our very first cohort-based 30-day JavaScript course. It's going to start on February 14th, but you need to go ahead and register ahead of time. Right now, we've got about 120 people signed up. And this is going to be a different kind of JavaScript course than we've ever done before. It's going to be focusing on not just writing JavaScript, but we're going to have a daily mindset podcast. We're going to have you build in public by posting to LinkedIn, hopefully daily, ideally daily, as you learn the fundamentals of JavaScript. And as a reminder, this first one is free, and you're going to be kind of our guinea pigs, but from here on out, they are not going to be free. And also, we just recently announced that if you complete all the things that we asked you to complete inside of Dev30, you will get an automatic $1,400 discount to Parsity, our online code school. So every person who fully completes Dev30 will get that $1,400 discount if they choose to move on and become a software engineer. But one random person who completes all of Dev30 will get a 50% discount on Parsity. That's a $3,950 discount on our program. And we've never done anything like this before, but we really believe that Dev30 will get you on the right track to be successful in software engineering, that we want to incentivize as many people as possible to go through it before attempting to apply to Parsity. So again, that's dev30.xyz, and I hope we get to work together starting on February 14th.